Awesome. Yeah, so thank you. I'm really grateful to be able to join you all via Zoom. Wish I could be there in person. So my name's Mariah Livernoy. I am a postdoc at the University of New Hampshire. I work primarily up here with Dr. Nathan Fury, but the project I'm going to be talking about today is a collaborative effort between us up at UNH and folks at CERC, namely Matt, Henry, and Kim, who you've heard from. The project I'm going to be showing you just some preliminary results where we are trying to leverage sort of existing telemetry data and the ACT and FACT networks to assess metrics of movement and phenology of a bunch of different fishes and one invertebrate species in the Chesapeake Bay. So I wanted to start by quickly thanking our funding support and collaborators thus far. So the funding for this project is through the NOAA Chesapeake Bay office and the National Marine Fisheries Service. Wameli, who you heard from earlier, is our awesome liaison between our groups. I also wanted to thank folks at CERC who have actually put in the hard effort of tagging the animals that I'll be talking about today over the years. And then of course, just all the members of the ACT network, all of you in the room, and especially a few people that I've listed here who've helped contribute some data to this project. So this project definitely wouldn't be possible without a large-scale telemetry network, as you'll see. So I'm going to be talking about the Chesapeake Bay. I work up at UNH, so all the way up in New Hampshire. I put a star there and a star where you are on the beautiful banks of the Chesapeake Bay, wishing that I could be there. But it's a very large and productive estuarine system that supports many different species of fish and invertebrates, all of which are very much ecologically important, and many are also economically and socioeconomically important. So that makes it a really interesting and exciting system to study animal movements in, not just for kind of understanding the ecology of lots of different species, but also potentially having some implications for management. So estuaries like the Chesapeake Bay are, of course, links between freshwater and marine ecosystems. And so we do see a lot of heterogeneity in environmental conditions and abiotic variables like salinity and temperature. And then in temperate regions, like where the Chesapeake Bay is, you get pretty distinct seasonal shifts in all of those environmental conditions as well. And so that creates a diversity of habitats, which means that there's a diverse group of inhabitants and species that can actually inhabit these estuarine systems. And so because we have that freshwater to marine gradient in habitats, we also have that gradient in terms of the fish and invertebrate species that can live in an estuary. And we also get a lot of diversity in terms of the movements and sort of spatial ecology of the animals that live in these systems. So primarily, we get this gradient between really highly resident species, things that kind of stay put in one very small part of the estuary for long periods of time, if not their entire life, all the way out to highly migratory species that use the estuary at some points in their life, but also travel really long distances outside of the estuary as well. So with all that in mind, the main question that we had for this project is really simply when and how do fishes use the Chesapeake Bay? And that sounds pretty simple, but like I said, there's a lot of diversity in the fishes that use the bay. And so what we're doing is we're taking long-term data from CERC's acoustic tagging projects over the years. Matt Ogburn's group at CERC has been tagging these 8 different species of mostly fish and then one invert in our horseshoe crab over the last about decade. And so we have that really nice gradient of sort of freshwater associated species like the blue catfish and the common carp, all the way out to marine and coastal species like the dusky shark and the smooth dogfish. So we have the number, N is just the number of individuals that were tagged, and then the number of detections are listed there. So what we're doing is we are collating all of the detections for these 8 species using the ACT network. And so Kim has been instrumental in helping me get all of that data and collate it all. But what it's given us is a really great spread of detections, both within the Chesapeake Bay, but also across the US East Coast from Massachusetts down to Florida. So these points here are all receivers that have detected at least one individual of one of these species. So a really big spread in spatial scale. So there are a bunch of different objectives to this project, but I'm going to focus on just my current objective that I've been working on recently, which is comparing common metrics of movement and phenology among those 8 different species across spatial scales. So on sort of the large scale, big picture kind of questions, we're going to be trying to do some network analyses just to assess how much space each of those species uses, how connected are their habitats, things like that. And then in terms of when they use the Chesapeake Bay, we're just calculating sort of simple metrics like entry and exit timing to understand the timing and duration of use of the Chesapeake Bay across species. And then on the smaller scale, sort of within the estuary, we're also going to try to assess sort of finer scale metrics like core use areas and use of very specific habitats across those species within the estuary. So I'm just going to focus on these 2 smaller scale metrics for the time being. And so one of the things that really stood out to us when we first looked at the data set sort of on a whole is that the timing and duration of use of the Chesapeake Bay differs pretty dramatically among these different species, which isn't necessarily surprising, but it's been really interesting to kind of try to quantify those things. So what you're looking at here on the y-axis is the predicted probability of an animal being detected in the Chesapeake Bay versus outside of it. And then on the x-axis, we have a month. So this is from January to December. And I'm going to show you each of the species and kind of just bring them in one at a time so it's not too overwhelming. The first thing that I'm going to point out is that black line along the top. That is actually data. It's not just a black line. Basically, our common carp, blue catfish, and horseshoe crab, those are our really highly resident species that we only detected within the Chesapeake Bay. So of course, their probability of detection in the bay is 1 throughout the entire year. And then bringing in some of our more mobile species, the striped bass. These are relatively small striped bass. They're mostly subadult, maybe a meter or less. And so most of the time we're detecting individuals of the species in the Chesapeake Bay. You will see there's a little dip in about March and April. Most of that is individuals leaving the Chesapeake Bay to go into the Delaware Bay, which is just an adjacent estuary. But we did have some individuals that actually left and migrated, sort of the more typical migration route of older striped bass. Now looking at the alewife, so this is an anadromous species like Henry Leggett mentioned. You can talk to him about alewife and all things river herring, but I'm just showing here that they tagged them in the rivers in their spawning area in March, and then we detected them for a couple months and then they left. So this is basically capturing their out migration as they move into the ocean after spawning. So next is sort of our most highly migratory species is our cow-nosed ray. So in the wintertime, you'll see here basically December through March, we do not detect individuals of the species of cow-nosed rays in the bay, but they do all pop in about April or May, and they stick around in the estuary basically until October, November. So they're spending a lot of time in the Chesapeake Bay when they are here. Now, on the other hand, we have migratory species like the dusky shark and the smooth dogfish that migrate basically past the Chesapeake Bay, as opposed to it being sort of the stopping point or northern or southern end of their migration. So they're basically moving through north in the summertime and south in the wintertime, and they're just stopping by in the estuary in the spring and in the fall, and just using it for very short periods of time before they kind of continue on their way. So we're really just seeing some really interesting differences among species in terms of their use of the estuary. So then we also wanted to look into some residency indices and just assessing kind of habitat use both within and outside of the estuary in distinct regions. So along the x-axis here, you'll see there's a number of regions that we've designated based on sort of environmental characteristics and also just spatial coverage of receivers. And it follows basically a north to south gradient from left to right. So north of the Delaware Bay is the farthest north up to Massachusetts, and then south of the Chesapeake basically means anything south of the Chesapeake Bay to Florida. And then the Chesapeake Bay is highlighted in that red box. And then the response here is just a residency index. It's fairly simple. It's just the proportion of days that that species was detected in that region over the total number of days that that species was detected anywhere. So really what we're looking at here is just our resident species. Unsurprisingly, the blue catfish were detected only in the rivers in the Chesapeake Bay, so those tributary habitats. The Road River, which if you are at Cirque, it's in your backyard right now, that is an area where all of the individuals of these two species, the common carp and the horseshoe crab, were tagged. So this is really showing that really high residency to quite a small area of the Road River, and no detections outside of the bay, not surprisingly. Now, when we look at our migratory species that do leave the estuary, obviously it's a different story, but it's not necessarily surprising. So a couple of things I wanted to point out here. The alewife, we detected them primarily in the rivers, that's their spawning habitat, and then we detected them leaving through the lower bay and up into the sort of northern regions, just for a few individuals. For our cow-nosed ray, we saw that they did use basically every part of the Chesapeake Bay. So they are using a really wide variety of habitats within the bay, and then they're being detected south of the Chesapeake Bay, but not necessarily north. So we know that about them. They travel south in the wintertime, and then they come and spend a bunch of time in the Chesapeake Bay in the summer. And then for our smooth dogfish and dusky shark, the pink and purple there, we do see them both north and south of the Chesapeake Bay. Like I said, they kind of travel back and forth and stop in very briefly and just in the mouth of the Chesapeake Bay. So we don't really see them using any of these sort of upper or even lower parts of the estuary, really just popping into the mouth. So those were very preliminary things. We have a lot more to do. So what we're going to do in the future is to sort of refine and expand upon some of those common movement metrics. We're going to calculate things like pore use area and do some network analyses, like I mentioned. We're going to gather as many sources of environmental data as we can and try to link and sort of correlate those environmental characteristics with the movement metrics across species. We're planning to create some visualizations of movements using some packages in R, especially to show to stakeholders and the general public. And then we're also planning to build some habitat distribution models for certain species that have really robust data sets. So just to leave you with a few take-home messages from what we've found so far. So the timing and duration of use of the Chesapeake Bay really depends on these sort of migration and residency patterns among species. We're also seeing some differences emerging among the species in their use of habitats within the estuary, but we do have a lot more to look into there on much finer scales. And then I really just wanted to say that this project is trying to kind of highlight the importance of these large-scale acoustic telemetry networks for quantifying the importance of estuarine ecosystems and then how those estuaries actually connect to other critical habitats via the movements of these animals. So with that, I will take any questions, and thanks for letting me join.
Thank you. Does anybody have any questions for Mariah here or in the chat room? No? All right. Thanks again, Mariah. Next up, we have Nick Coleman. And as we mentioned earlier, Nick Coleman was the recipient of our Student Network Travel Award, which kicked off today and is live. You all got emails from me at lunchtime. So yeah, pass that around. But we're ready for you, Nick, when you're ready.
Cool. Can you guys hear me?
Yes, we can see you and hear you.
Perfect. Now, if I can share my screen without any issues, that'd be the icing on the cake. Oops. Is it in a presenter mode or are you seeing the slides on the side?
We're seeing slides. It looks good.
Oh, it's in presenter mode?
We're good.
Okay. Well, good afternoon, everybody, and thank you for having me. Sorry that I couldn't be there in person today, but I'm very excited to share my thesis or my research with you. In the fall, I completed my thesis with Dave Secor at the University of Maryland Center for Environmental Science, where we estimated the spawning run of Atlantic sturgeon in the Marshall Creek Nanticoke River system. The image in the background of the slide is actually an aerial photo of the Marshall Creek Nanticoke River. And I wanted to use that to highlight that this is a very small system. I'm going to talk a little bit more about that later in this slide. But before I do that, I just want to give you a brief background on the history of Atlantic sturgeon. Atlantic sturgeon were previously thought to be extirpated due to historic overfishing and habitat loss, but recently, within the last 20 years or so, spawning runs have been rediscovered in tributaries of Maryland and Virginia, such as the Marshall Creek Nanticoke River on the eastern shore of Maryland, at the confluence of Delaware and Maryland. In 2014, Atlantic sturgeon were listed as an endangered species, and in 2017, the Nanticoke River Marshall Creek was designated as critical habitat. Since being listed as an endangered species, Maryland Department of Natural Resources has conducted annual gill net and acoustic tagging, and their research has been really fundamental in my thesis and helped point out several key characteristics. The first of which being that it's not only a small system, but there's also a very small fall spawning run, which primarily occurs from early August to late October. During this period, the Marshall Creek is an area of high spawner aggregation, and fish begin to exit the system when temperatures fall consistently below 20 degrees Celsius. The figure on the left is from the fall of 2021, when I had the opportunity to go sampling with Maryland Department of Natural Resources and the Marshall Creek Nanticoke River system. And we caught the fish that I'm holding, which is nicknamed Igor. And if you look closely, you might see why. Igor was struck by a boat propeller, causing him to lose some of his dorsal scutes and also giving him his nickname. And in case anybody's wondering, Igor comes back to spawn in the Marshall Creek every year. I adapted a model that was used to estimate the abundance of Atlantic sturgeon in the Hudson River to the Marshall Creek Nanticoke River system. And in this model, telemetry data provides information on the timing of immigration, and movement within the system, while side scan sonar surveys provide count data on individuals within the area of high spawner aggregation. So for my study, this was the Marshall Creek. I then apply movement patterns of tagged fish to count data to estimate spawning run abundance and reach specific use. And I'll talk a little bit more about reach specific use in the next slide. But like any models, there were several assumptions that we had to make in order to account for this highly dynamic process. The first was that the Marshall Creek and Nanticoke River support one population of sturgeon. And this is something we felt confident in based on previous telemetry examinations from these studies conducted by Maryland Department of Natural Resources and my advisor. Next, we also assume that once sturgeon enter the Nanticoke River, they stay in the system over a period which allows us to track and model their behavior. In other words, we don't have fish that enter the system and then leave the next day. Once they enter the system, they're spending a substantial amount of time there. And again, this is something that was consistent with previous telemetry data. Finally, the behavior of tagged fish is representative of the entire spawning run. Tagged fish were monitored through an acoustic array, and the location of receivers in that array is shown in the figure on the right. I portioned the array or receivers in the array into 4 reaches, and individual receivers are color coordinated to correspond to reach, where green represents the lower Nanticoke River, blue represents the lower Marshall Creek, orange represents the upper Marshall Creek, purple represents the upper Nanticoke River, and red represents the VIMCO positioning system, or VPS. I want to point out that the VPS isn't its own separate reach. It's within the lower Marshall Creek, and initially it wasn't deployed to supplement my thesis, but because it provided additional coverage in an area of high spawner aggregation, we decided to include it. In 2021, 16 additional receivers were deployed, 12 of which were in the upper Nanticoke River and 4 of which were in the upper Marshall Creek. And the location of those additional receivers is shown in the updated figure. In both years of the study, telemetry data was analyzed from August 15th to the end of October. Side scan sonar surveys were conducted weekly in September by Dr. John Madsen using a 1600 kilohertz towfish. We also conducted a survey in the first week of October in 2021. Side scan sonar surveys surveyed the entire lower Marshall Creek, which is about 22 river kilometers, and consisted of 2 passes, 1 upstream and 1 downstream, and typically occurred between 11 a.m. and 5 p.m. and took anywhere between 2.5 and 3 hours. And this is important because we assume that the lower Marshall Creek was closed during the survey period and that no fish were moving in or out of the system, and that the number of fish in the system was constant, or I'm sorry, in the lower Marshall Creek was constant. Side scan sonar data was analyzed in the software Sonar Wiz, and a 1.4 meter threshold was used to identify sturgeon. For each identified sturgeon, the geospatial position, estimated length, and time of observation was recorded. I then summarized count data to get the number of sturgeon detected on a single pass for each day of the surveys. And the figure on the left shows an example of an insonified sturgeon in the side scan sonar image. And if you look closely, you can see the acoustic shadow cast here. I'm not sure if you can see my cursor, but you can also see the heterocircle tail. Telemetry data was used to create a daily observation matrix, and I'm trying to recreate an example of what that would look like in the table on the left, where each sturgeon is represented by an individual row, and each column is represents a single day time step. The location of a fish within the system is numerically encoded, where 1 is not detected, 2 is Lower Nanticoke River, 3 is Lower Marshub Creek, 4 is the Upper Marshub Creek, and 5 is the Upper Nanticoke River. Obviously, fish can be detected in multiple reaches in a single day, but in order to assign a fish a single reach, I had to make, for the purposes of my study, I had to make several assumptions or several rules. The first which being if a fish was detected in the Lower Marshub Creek and any other reach, it was automatically assigned the Lower Marshub Creek because this is the only area where we had side scan sonar surveys, and it was an area of high spawner aggregation. Additionally, if a fish was detected in the Upper Nanticoke River and the Lower Nanticoke River, it was assigned the Upper Nanticoke River because this is an area of putative spawning. The observation matrix was used to estimate latent state, detection probability, and reach transition probabilities, which all ultimately went into estimates of abundance. Now into some results. In both years of the study, 17 sturgeon were tagged, and reach detection probability ranged from 0.76 to 1. The lowest detection probability of 0.76 was estimated in the Upper Marshub Creek in 2021, but was likely a result of extremely low detections. For reference, we had less than 20 detections in the Upper Marshub Creek in 2021, which severely reduced our ability to estimate detection probability. The figures on this slide show spawning run estimate abundances, where abundance is on the y-axis, date is on the x-axis, estimated daily abundance is in red, and estimated cumulative abundance is in black. Error bars represent 95% confidence intervals. In 2020 is shown on the top figure, and 2021 is shown on the bottom figure. The rest of the figures in this presentation are going to be structured the same way. In 2020, we estimated that 36 sturgeon used the Marshub Creek Nanticoke River system. And in 2021, we estimated that 74 sturgeon used the Marshub Creek Nanticoke River system. In 2020, 50% of the spawning run entered the system by August 19th. And in 2021, 50% of the spawning run entered the system by August 25th. So a relatively similar period of entry in both years, but the cumulative number of individuals that entered the system peaked around September 17th in 2020 and October 25th in 2021. Subsequently, the estimated daily abundance declines shortly at or around the same time cumulative abundance reaches an asymptote. And again, this all occurred about a month earlier in 2020 compared to 2021, and suggests that 2020 was a much shorter spawning period compared to 2021. When we compare abundance between areas of upstream areas of putative spawning, which consist of the Marshub Creek reaches and the Upper Nanticoke River reach, we see that the Marshub Creek reaches consistently supported more sturgeon in both years of the study. But it's also important to understand that survey bias might play a role in this. I just want to remind you that we exclusively surveyed the Lower Marshub Creek with side scan sonar surveys that might bias our estimates, and we're going forward, we're going to use side scan sonar surveys and other reaches to hopefully get better estimates. Now, one thing that may have jumped out to you in the results that I just presented is that there was a twofold difference in abundance in between years. And we believe that this is related to the environmental conditions experienced in both years. And that's what the figures on the right are trying to show. Daily recruitment probability is shown on the y-axis and date is on the x-axis. Black data shows estimated daily recruitment probability and with 95% confidence intervals, and average daily temperature is shown in red. The blue line represents the 20 degrees Celsius thermal threshold that I mentioned before. Average daily temperature was declined much more rapidly and much more earlier in 2020 relative to 2021. And when we look at when this occurred, we see that temperature begins to steadily decline towards and below 20 degrees Celsius around September 15th, which coincides when daily recruitment probability reaches nil. And if you recall in the previous slides, this is around the same time in 2020 when cumulative abundance reached an asymptote and daily estimates of abundance started to decline. When we look at when this happened in 2021, we see it doesn't happen until much later. Around October 13th, temperature doesn't begin to decline below 20 degrees Celsius, and recruitment approaches nil around the same time. So this indicates that one of two things could have happened, or maybe even a combination of both. Because the spawning period was shorter in 2020, conditions may have been less favorable and reduced the strength of the spawning run. Or it could also mean that because of the contracted spawning period, it reduced our overlap with side scan sonar surveys and we underestimated the spawning run strength. So just to conclude on what I presented today, estimates support a very small run size of the Marshall Creek Nanticoke River system. And in 2020, we estimated that 36 sturgeon used the system. And in 2021, we estimated that 74 sturgeon used the system. The twofold differences in abundance may be explained by spawning season duration and survey coverage. And spawning is also likely occurring in the upper Nanticoke River, but we hope to confirm that going forward with future sampling. That I would like to thank all of my collaborators and sources of funding support, many of which are in the room, and I'd be happy to take any questions.
Thanks, Nick. Anybody have any questions for him? All right. Moving on to away from our virtual talks. We're gonna have Matt Kendall from NOAA joining us.
Just 1 second while I set up for the in-person talks again. Right. Does that look good, Emily? All right. Right. You can use the arrow keys.
Oh, okay, great. Sure. All right, thanks very much. I'm Matt Kendall with the NOAA Biogeography branch. The rest of the alphabet soup is probably unfamiliar to some people. Hopefully NCOS rings a bell to a few folks, National Center for Coastal Ocean Science. So I've been doing telemetry with our group for about the last 20 years, off and on, mostly in the US Virgin Islands and in South Florida. A little bit on the East Coast here, working with Gray's Reef National Marine Sanctuary. My colleague and co-author over there, Bethany Williams, has probably bothered one or more of you when we were doing a summary of all the fish up and down the East Coast that have gone through Gray's Reef there off the coast of Georgia. So today I would like to thank Matt and Kim for inviting us to share with you a project that we're just starting now, closer to home for you guys here in the Mid-Atlantic. And that is at a place called Poplar Island, which is located kind of middle section of the bay. If you haven't been there, there along the eastern shore. It was about 1,000 acres in 1847. But if you know anything about this part of the bay, you know that erosion, sea level rise, subsidence of the land has caused a lot of these smaller islands to basically disappear. In fact, in 1990, it was only 4 acres. So here's an oblique aerial from 1936 that gives you a sense of what Poplar looked like. It's that sort of parenthesis up there at the top, and you see these 2 islands here at the bottom. I had to rotate this picture to make it kind of make sense with what Poplar looks like today. But those are those 2 islands, and you can see them there in the satellite image. Oh, it doesn't show up here, does it? Now it's called the Paul S. Sarbanes Ecosystem Restoration Project at Poplar Island. And this is an idea that's been developing over the years, and at Poplar Island, it's really reached its pinnacle, where things have to be done to keep shipping channels open. Dredging has to be done. They got to do something with that stuff. And rather than just put it in a big giant pile somewhere, which is what used to be done with it typically, how about we shape it into something more useful? So at Poplar, the Army Corps of Engineers, they're funding our 3-year study. The Army Corps and the Maryland Department of Transportation uses dredge material from Baltimore shipping channels, which raises some eyebrows usually in terms of what the quality of that material is, but that's all part of the study. In the end, it's going to be this 1,700 acres of upland and lowland marsh habitat. This is all in vogue these days. They even have a trademark at the Army Corps. Engineering with nature is what they call it. There's also been a big push, at least with the recent White House administrations on this or administration, I should say, singular, nature-based solutions roadmap, right? Let's make nature do better things for us than just armoring shorelines. We can use mangroves and spoil islands and things like that to get a lot other ecosystem services out of these things. So again, if you haven't been there, it's a pretty cool place. It's almost straight across, I think, from where we are now. The way it works is they make these big rings of riprap that you kind of see up there in the upper middle. And then they fill that in with the dredge spoil. And it takes a couple cycles of loading. They let that sit there for years, really, and it just gravity kind of squeezes all the water out of it. They drain off that water, and then once it's quote unquote dry enough, then they shape it into different marsh habitats. And if you're standing on the edge of one, I mean, it looks to the naked eye, it looks fantastic, just like you'd expect a marsh to look like. And then they connect those creeks and things with, sometimes it's like an open culvert design like you see in the lower middle. Sometimes they have these pipes that they allow the tidal flushing to go in and out of the marsh cells, and sometimes it's this open box culvert kind of design that they can seal those off as they're doing plantings and manipulating things. And then really the idea is to just let it flow. Once the marsh has been created and once it's all in place, they just let it do its thing. There's a ton of work going on here, not just to keep an eye on the fact that these are dredged from shipping channels and what that might mean as far as the chemistry of what's in the water and potential contaminants, but a ton of research is going on here. Chesapeake Bay office does juvenile fish monitoring. There's a little bit of gillnet monitoring a couple times a year to look at larger fish. All of the marsh plants and things get investigated to make sure that those things are functioning right, nutrients are cycling properly. Bunch of seabird research, a real interesting variety of things. What they don't have a good sense of is how larger fish are using the engineered marsh cells. And that's where we come in. That's what they've asked us to do. Determine how fish are using these areas. So if we zoom in onto this lower cell 5B, you can kind of get a sense of what we're trying to do. So we're going to have 77 VR2Ws. That's a lot of VR2Ws to keep track of. And it's going to take that many to really understand what's going on in these different cells. It's pretty cool because they are sort of like replicate cells. And that's one of the reasons that we're really excited to work here, is because you can kind of look at these as little individual marsh replicates. You can see that they've got different features like these moats is what they call them around raised up bird islands. They've got these pond features. They've got bigger channels and smaller channels. If these green dots are VR2Ws, of course, what we're going to hope to see is things like the proportion of time that the fish use different parts of the habitats. Do they use those upper reaches of the marsh creeks, or do they mostly focus on the individual, or on the deeper areas in the ponds? Do they go in and out of the same culvert design with equal frequency? Did they use those pipes? Did they use only the open, designs, that kind of thing? Do they use, some of the cells are connected laterally? Do fish move side to side, or do they always go out the culverts and come back in a different one? And of course, the awesome thing about working in a place like Chesapeake Bay with organizations like ACT and Matos is we're going to share all this data and see if our fish go anywhere else in the bay. I think the Corps is going to be especially interested in that particular question. So here's there's that one cell I just showed you, and this just gives you an idea of how we're going to try and monitor the other cells in the system. You'll see two different densities of VR2Ws. There's so many twists and turns. We can't monitor things 100%. So we've taken an approach where we're going to monitor 3 of the cells really well. And then the rest of them, we're just going to keep track of, are you in or are you out, in terms of what the fish are doing. And you can get an idea of which cells those are. Then they have that northernmost part of the island is that cell that's in the lower left of this figure. And that's going to be a deeper water type of a cell. They're not going to fill that one in. It's going to be a place where they're already starting some artificial oyster reefs. So we're gonna see what's swimming around in there too. So what are we going to tag? We're going to tag just about anything. We typically use V8s. They now are programmed that they last a little bit over a year, about 400 days. So we're going to be doing 2 seasons worth of tagging. And the Corps has explicitly asked us to not just keep our blinders on with 1 or 2 species. They basically want to know, how is this thing functioning as an ecosystem? So they want us to tag a wide variety of stuff. All these things are on the list. Had an interesting conversation about American eels a little while ago that we're excited to see the eels that are resident there, what they do when they leave, what the timing of that is, if they stay in the same creek or if they move among cells, those kinds of things. Snakeheads, they catch those. I'll come back to the diamondback terrapins, but cow-nose rays, they also have seen those swimming around in the cells. So we're gonna see what happens there. So of course, the Corps is primarily interested in understanding, how things are functioning at Poplar, but they really want to know which of those marsh designs works best, which one is most attractive to fish, because this is the new normal for the way they're going to treat and dispose of dredge material in the bay. There are already 2 other islands that are in various stages of planning, like you see here. There's James and Barron Island. Both of those are a little bit to the south. Same exact idea. They have an idea of the footprint that they're going to use for when they create those islands. This is James Island, or what's left of it. This is actually just a few years ago, so it might not even look like that anymore. It's probably totally even smaller, okay, if that's possible. So it's definitely an issue that is up and down the eastern shore of the bay. So a couple other things before I close out here. We are focused at Poplar Island, which you see over there on the left. And those question marks are what a partnership that we're going to be doing with Dr. Wilmeli Cruz Marrero over there, who spoke earlier today from the Chesapeake Bay office. So they're going to set up an array just like we did at Poplar, and they're going to tag a similar suite of species so that we can compare what's going on with the restored habitats at Poplar to the quote unquote natural, or at least more natural habitats somewhere on Tillman. We're still trying to figure out where we're going to set up that array. So that's one additional aspect of this work that I wanted to highlight. Another one is, so we're doing this tour where we're explaining to folks what we're doing. And one of the offshoots of that was I had some outreach with Dr. Willem Rosenberg from Ohio University, who literally wrote the book on diamondback terrapins. And I told him about the array, and he said, can I come and piggyback on that? And I said, absolutely. So they're going to tag, I think, about 40 terrapins, about 20 are going to be head started, 20 or not, and they're going to see if there's differences in the habitat utilization and behavior of those. And I'd like to invite anybody else. I mean, we're going to have this place wired up. So come on, tag along with us. And really, we're going to be there for 2 years. And if anybody's got students, transmitters, a particular critter that you're interested in seeing how it responds to a man-made environment like this, please join us on the array. It's free to take a ride on it. If you want to come tag at Poplar, just reach out to me and we'll talk. So here's where we are. Permits, planning, and partnerships. That's basically what we've been doing so far. In May, just a few months from now, we're going to get that array in the water, and we're going to do our first round of fish tagging, and then we're kind of on a 6-month cycle of downloading, tagging more fish for a couple years till we get to May 2025, and that's when we're going to demobilize everything. And it may keep going if the Corps is really keen on the information that we get kind of along the way. But our plan right now is to go at least through May of 2025. Of course, we'll be sharing all those downloads with the ACT and Matos network. If any of your fish swim through our site, you will certainly hear about it. And then maybe by December, we'll do probably a journal article as our final output from the project, along with all the data archiving. And yep, I think that's it. If there are any questions, I'd be happy to answer.
Any questions for him? Well, as an aside to that, if you're coming to the social, you can meet our very own diamond terrapin, Dinky. Oh yeah, that's right, there's 2. Dinky and Dash. They all have to read it. So hanging out, waiting to entertain.